Welcome to MRL. This is the second part of sequences. In this part, we'll be learning about a sequence known as arithmetic progression. So what is an arithmetic progression? First of all, arithmetic progression is a numbers pattern. It is a sequence. What type of sequence? A sequence in which the consecutive terms have a constant difference is called as an arithmetic progression. Let us take an example. 2, 4, 6, 8, 10 are the terms of AP, are the terms of arithmetic progression or a sequence. So now if you observe here, 2 and 4, the difference is 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 2 is 8. That means the consecutive terms have a constant difference 2. That is the constant difference is called as common difference, and that common difference is represented by plus 2. That is the symbol of common difference is D. So the constant difference is called as common difference, and it is denoted as C dot D dot or D. If in an AP we have the terms T1, T2, T3, T4 and so on to Tn, and these are the terms of AP. Now if T2 minus T1 is equal to T3 minus T2 is equal to T4 minus T3 is equal to Tn minus Tn, Tn minus Tn minus 1, and all are equal and the equal is D because it is a common difference, then the given sequence is an arithmetic progression. Remember that. That means to check if a given sequence is an arithmetic progression or not, just find out the difference between the consecutive terms. If the difference between the consecutive terms is constant, that is the common difference is same, then it is 100% an arithmetic progression. This is an arithmetic progression because the difference between the consecutive terms is 2, that is D is plus 2. Now there are two different types of APs we have. One is the finite AP, the other one is infinite AP. In a finite AP, the number of terms is finite. That means if an AP has got finite number of terms, then it is finite. It is a finite AP. If that means the number of terms are countable. That means 2, 4, 6, 8, 10. If you find here 1, 2, 3, 4. Only if there are 5 terms, there is finite term. Therefore, it is finite AP. Infinite AP means an AP with infinite number of terms is called as infinite AP. Now what is the general form of AP? If the first term is A, if T1 is A and the common difference is D, then the second term will be A plus D. Remember this, because the first term, when I add D to that, I'll get the second term, and remember that because common difference is D, because A plus D minus A is D. Now the third term will be T3 is equal to A plus 2D, because I have to add D to the second term. So because every next term is D more, and therefore it is A plus 2D. Therefore the general form of AP is A plus D, A plus 2D, A plus 3D, and so on is the general form of AP, because the general form of AP is T1, T2, T3, T4 and so on. So here we have T1 as A, T2 as A plus D, and T3 as A plus 2D, and T4 as A plus 3D and so on. That is the general form of AP. Remember, if A and D are known to us, then we can form an AP. That means if you are given A and D, that is the first term and the common difference, we can form an AP, or we can find out the AP or the terms of AP. Now what is the general term of an AP? Please understand the difference here. This is the general form of AP. Now we are talking about general term of an AP. We know that the first term of AP is A, T1 is A. Second term is A plus D, that means D more, that is A plus D. And if you observe here, the subscript of T2 is 2. If I subtract 1, I get 2 minus 1 is 1, 1 into D is D. That means when the subscript is 2, only 1 D. When the subscript is 3, then it is A plus 2D. When the subscript is 4, it is A plus 3D, that is 1 less than 4. So on, if we continue up to Tn, then if the subscript is n, then A is same, A plus the 1 less, that is n minus 1 into D, and therefore the nth term, the last term, the general term of an AP is Tn is equal to A plus n minus 1 into D. It's a very, very important relation in AP. Now here A is the first term, n is number of terms, and D is the common difference. So please remember this important relation, very useful in calculations. Now let us talk about arithmetic series. We already know what is a series. Now let us talk about arithmetic series. The sum of the terms of an AP is arithmetic series. That means we are given an arithmetic progression. If we add the terms of AP, then we get AS or arithmetic series. Now we know the general form of AP. The general form of AP is A plus D, A plus 2D, A plus 3D, and so on. Therefore, the arithmetic series will be the sum of these terms, that is A plus D plus A plus 2D plus A plus 3D plus and so on. So that is what is the arithmetic series. Remember that. And of course we have in arithmetic series also we have got finite series and infinite series depending upon the number of terms of the APs. Now coming to the sum of n terms of an AP. Now you are given an AP and we have to find out the sum of the terms of an AP. Now the symbol of the sum of n terms of AP is Sn. So let us consider here the general form of AP first. If A plus D, A plus 2D and so on, A plus n minus 1D is an AP, then we have to find out the sum of these terms. Now assuming that Sn is the symbol of sum of n terms of AP, then Sn is equal to A plus D plus A plus 2D plus A plus 3D plus so on to A plus n minus 1 into D. So this, let us call this as 1. Now again the same sequence I can write it in reverse order. That means writing the last term as the first term and the first term as the last term. Again it is Sn. So Sn is equal to, the last term is A plus n minus 1 into D here, and so on, the first term is A. Now when I add these two, Sn and Sn, I get 2Sn. When I add these two, I have to add the first term and the first term, the second term and the second term, the last term and the last term. When we add, we find that A and this is the nth term, that is Tn, so it will be A plus Tn, and the last term is also A plus Tn, and in between also we get A plus Tn, A plus Tn, A plus Tn. And how many A plus Tn's we have? We have got n terms of A plus Tn, and therefore 2Sn is equal to n times A plus Tn, or Sn is equal to, bringing 2 down, Sn is equal to n upon 2 in the bracket A plus Tn. So this is the sum of n terms of AP given the terms of AP to us. So therefore, now putting value of Tn here, we know that Tn is equal to A plus n minus 1 into D. So Sn is equal to n upon 2 in the bracket A plus n minus 1 into D, and that is because Tn is equal to A plus n minus 1 into D. We can add A plus A, that is 2A plus n minus 1 into D. Therefore Sn is equal to n upon 2 in the bracket 2A plus n minus 1 into D. Again remember, this is a very important relation to find out the sum of n terms of an AP, and this formula can be used, or this relation can be used if we know n, we know A, and we know D, where n is the number of terms, A is the first term, and D is the common difference of AP. Now let us understand here the different forms of Sn. Now Sn is equal to n upon 2 in the bracket A plus Tn. This can be used when n is known and the nth term is known. Nth term of this arithmetic progression is known to us. Now the same thing, instead of writing Tn, I can write it as L, that is the last term. Therefore this formula and this formula is the same. Instead of Tn, I have used it as L, that is the last term. Now another important formula is Sn is equal to n upon 2 in the bracket 2A plus n minus 1 into D, and this formula can be used when n is known, A is known, and D is known. So the next one is Sn is equal to n in the bracket A plus L upon 2. That means n into average of the first and the last term of an AP. If you are given the number of terms and the average of the first and the last term, then we can use this formula. So please remember, the choice of the formula depends on the details given to us, the values given to us. If the number of terms, the first term and the nth term is given, use the first formula. If the number of terms, the first term and the common difference is given, use the second formula. If you are given the number of terms and the average of the first and the last term, then use this formula. All these formulas can be used depending upon the values given to us. Remember that. Now to find the common difference, we already know how to find the common difference. We have learned that the common difference can be found out by subtracting the consecutive term, that means T2 minus T1, T3 minus T2 and so on, if T1, T2, T3 and so on are the terms of AP. And also remember, there is one very important relation to find D, and D is equal to Tp minus Tq upon P minus Q, where Tp is the pth term and Tq is the qth term, and P minus Q is the pth value and the qth value of the sequence. So remember this, that is P and Q. So that means we can use this relation to find D, a very useful relation to find out D. So for D can be found out in two ways. One is subtracting the consecutive terms of AP, or use the relation D is equal to TP minus TQ upon P minus Q, where TP is the pth term and TQ is the qth term, and subtracting dividing by P minus Q we get D. Remember that. Okay, so remember this much. In the next study, in the next part rather, we'll learn a few important applications of AP and the relations. Thank you.